So 2.6, we're going to solve inequalities and graph their solutions. So first we have to remember how to solve inequalities. Solving an inequality is just like solving an equation. We do everything exactly the same. The only thing that changes is when we're multiplying and dividing by a negative. And I put this in all capital letters so that I could remember. If you divide or multiply by a negative, the inequality flips direction. So if it was a less than and you multiply by a negative, it becomes a greater than. Okay, that's the only thing that's different about solving inequalities, is when we multiply or divide by a negative. Okay, so we have a few steps we need to write down. The first step, ooh, that's a lot. Oh my gosh. Okay, so really quickly, graphing inequalities, that's our main idea. The first step is we want to get x on the left-hand side, and I want you to always get x on the left-hand side. So if x ever ends up on the right-hand side, you can just flip the whole thing like you're looking in a mirror. So you can flip it so that x is on the left, but you also need to flip the sign at that point. And we'll do a couple examples like that. Then you're going to plot the constant on the number line. And you need to determine if the point should be open or closed. So I made a little chart for us to remember. If we have just an equal sign, we just have a solid point. If we have greater than or equal to or less than or equal to, you also have a solid point because we can equal that point, right? The answer can be equal to that point.
Oh, I remember.
You remember that?
Great.
Okay, if it's just a greater than or a less than, you can't touch that point, so we put a fence around it. So we have an open dot. Step 4, we graph the line representing the inequality. If you just have an equal sign, there is no line, it's just a point. If you're less than or equal to, we're looking for all numbers that are less than that number, so we go to the left. And if we're greater than or equal to, our arrow points to the right because we're looking for all numbers that are bigger. Okay? So example 1. We have 2 greater than 6 plus x. And then I drew the number line. Yep, because part of the problem is to graph the answer. Alright guys, so the first step in our steps is to get x on the left-hand side. We just want to do that very first thing. In this problem, x is on the right-hand side. So to get it on the left-hand side, I just have to flip the entire inequality. So I'm going to rewrite it, x plus 6 less than 2. It's the exact same thing as what's written up here. Or actually it would be 6 plus x, right?
Yeah.
Let's just keep it the same. It's exactly the same, 6 plus x, as what the original problem says, because what is the alligator mouth open to in the original problem? The 2. What's it open to after we flip it? Still the 2. So it's exactly the same. All it is flipped. Now we can start solving. So what do I do to solve this one? I subtract 6 from both sides. Same thing as what I've always been doing. So I would get x less than 2 minus 6? Negative 4. That would be my answer.
Now you gotta do it on.
Now we have to graph it. Okay, so I'm going to go to negative 4. And I have x less than negative 4. So is my dot going to be open or closed?
Open.
It's going to be open because we can't touch negative 4. We can get really, 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 really close to it, but x cannot equal negative 4. So we put the open circle around it as like a fence to tell us, okay, I can get as close as I possibly want to negative 4, but I can't actually equal -4. So the circle is open to tell us that. And then we have x less than, so am I going to the left or to the right? To the left. We have x minus 6 plus 10 greater than or equal to -8. Now this time, is x on the left-hand side already? Yeah, so we don't have to flip it, but we do need to simplify. Okay, so we do need to simplify the whole left-hand side before we can actually graph. So what am I going to do here? I have x minus 6 plus 10. So I have x, -6 plus 10, what does that give me?
+4.
So I actually have x plus 4 greater than or equal to -8. -6 plus 10, I combined like terms. We're just solving as normal. Okay, then what do I do to get rid of that +4? I subtract 4 from both sides, because whatever I do to one side, I do to the other. So +4 minus 4 is 0. So I get x greater than or equal to, what's -8 minus 4? -12. -12. Oh, I didn't have space on my number line. -11, -12. Okay, so let's graph this. X greater than or equal to -12. Is my dot going to be solid or open? Solid, because I can equal 12. So we put a solid dot at -12. And it's greater than, so does it go to the left or to the right? To the right. And that's it. Alright, example 3. We have 5 minus 3x greater than or equal to -10. So, Brandon asked a good question. Do we have to flip it? Well, let's look at it. Is x on the left-hand side? Yeah, so we don't have to flip it. We're just going to solve as normal. Okay, so what am I going to do to solve here? I subtract 5 from both sides. So I get -3x greater than or equal to -15. Now what? Now I divide both sides by -3. Okay, those cancel, so we get x by itself, but I divided by a negative, so what happens to this sign? It flips, so now we have x less than or equal to -15 divided by -3. A negative divided by a negative is a +5. So our answer is x less than or equal to +5. So is this a solid dot or an open dot? Solid at +5. And is it less than or equal to, so do I go to the left or to the right? To the left. And that's my answer. So example 4. -6x plus 3 less than 27. Alright guys, so if I was solving this just like normal, what would I do first? I would distribute that negative, right? So let's distribute the negative. So it becomes -6x minus 3 less than or equal to 27. Is x on the left-hand side? Yeah, so I don't have to flip anything. So then what would I do to solve?
Add 3.
I would add 3 to both sides. So I would get negative 6x less than or equal to 27 plus 3? 30. Okay, now what? I divide both sides by negative 6. Ran out of room, so I'm going to move it up here. Negative 6 divided by negative 6, that cancels, right? So I'm just left with x. What happens when I divide by a negative? The sign flips. So now we have x greater than or equal to 30 divided by negative 6? Negative 5. So the sign flips. So that would be my answer. X greater than or equal to negative 5. So let's graph it. Is my dot solid or open? Open. It's solid because I can equal negative 5. Greater than or equal to. And is my arrow going to go to the right or to the left? To the right, because I'm looking for everything that's greater than. Yes. So example number 5, this one is the doozy. The doozy. Okay, we have 5x minus 2, all of that times x plus 1 less than 28 plus x. Oh my gosh, we have x on both sides now. I'm serious. Totally serious. So what are we going to do? The first thing that we're going to do is we have to simplify everything. So it's just like if x was on both sides of an equation, we're going to simplify. So Ashley, what am I going to do? Distribute that negative 2. So let's distribute it. So I would get 5x minus 2x minus 2 less than 28 plus x, or 20, oh my gosh, 28 plus x. Is the left-hand side simplified all the way yet? No. So I need to combine those like terms. 5x minus 2x. 3x minus 2 less than 28 plus x. Okay. So my left-hand side is simplified, my right-hand side is simplified. I want to get all of my x's on the left-hand side. So what am I going to do? I need to move this x over here by subtracting it from both sides. Okay. 3x minus x, 2x minus 2 less than 28. Now what? Add 2 to both sides. I'm going to move it up here. So we get 2x, those cancel, less than 30. Divide both sides by 2. X less than positive 15. Now my number line obviously doesn't have all that space. Okay, so I'm going to 11, 12, 13, 14, 15. It's in there somewhere. Okay. So I'm less than 15. So is my dot open or closed? It is open at 15. And am I going to the left or to the right? To the left. And that's it.